Hi everyone. Today we'll be presenting about heat transfer application in daily life and industries. My name is Fahd Salah Hassan Lahmadi and my matric number is 201454, and I'll start with the introduction. Can you go to the introduction? So our presentation today will be consisting of two parts, which is balance of the stove and heat exchanger. Next. So what's heat transfer? Heat transfer basically is the process of thermal energy exchange between different objects, and it contains three main fundamentals mechanisms, which are conduction and convection and also radiation. For the conduction, which is the transfer of heat through direct contact between object and substance, and for the convection is the transfer of heat through movement of fluids. And lastly, which is radiation, is the heat transfer between electromagnetic waves and electromagnetic waves. So that's all my part. I'll pass it to my group mate to continue.
Okay, thank you, Fahid. My name is Ra'ad Nasrallah, matric number 195804. So for the application in daily life, we chose the pan on the stove. So the three heat transfers, we have the conduction. First of all, the pan conducts heat to the food by direct contact with the heating element. The second one is the convection, which is cooking on a stove. The hot air rises and is replaced by cooler air. The final one is radiation. So heat that is transferred from the heating element to the pot or pan. So that's all for the application. Moving next.
Assalamualaikum warahmatullahi wabarakatuh. My name is Karuna Shamil Anwar. My meeting number 2059551. So for the case study here, this is a question tell us about the steak which is going to be cooked on a stove with a medium rare with just 1 inch for the thickness of the steak. The question said the medium heat here is around 350 Fahrenheit, and we can do a calculation using the rate equation, which is Q is equal to Ka times T1 minus T2 over L. So basically T1 is the temperature of the heating element, which is, and the question is the pan lah. And T2 is the temperature of the stick, while L is the thickness of the pan. The pan given here is the thickness of the pan here is given as a 2 mm, and you want to convert it into the meter, which is 0.02 meter. Here we have a thermal conductivity, which is K is equal to 50, and the area will be 0.03 meter square. Then we just plug in the number. Now we get the number. The answer is 50.625 watt. So from here you can see heat transfer is easy in our daily life. In this example, we can relate the theoretical of the heat transfer in reality to the pan of the stove, which use this conduction formula to get the heat transfer rate. And next, I pass to the next presenter.
So thank you, Nasran. So now we will continue by talking about the heat exchangers. So next slide. We will first should understand the purpose of the heat exchangers. So the purpose of the heat exchangers is to transfer thermal energy from one fluid in one system to another without two fluids mixing together. So in manufacturing, hot oil is actually wanted to be cooled down by using water, but the liquids should not mix together. So that's where heat exchangers come in. So many methods can be used, and heat exchanger is one of the most common ways to actually separate the two fluids. So the concept of the heat exchangers, next slide. So the concept of the heat exchangers is typically a plate heat exchanger will consist of several parallel plates positioned above each other, thus creating a passage in which the fluid can flow between. The spacing between two opposite plates provides a channel for the fluid to flow through, as you can see in the diagram on the right side. So each plate has an inlet and outlet hole at either end, and this ensures the hot and cold fluids to pass through alternating channels in the plate heat exchanger. Therefore, one side of the heat exchanger will always contain a hot fluid while the other side contains a cold fluid. And these fluids will transfer heat from hot to cold, and this results in heat transfer. It is as simple as that. So I'll pass to the next presenter to continue.
Yeah, thank you. Myself, Thomas Rabin, and my metric number is 24455. So I would like to continue from heat exchanger plate. So basically, what is heat exchanger plate? Heat exchanger plates are metal plates that transfer heat between two fluids that are separated by the plate. So basically, this heat exchanger plate is made of steel, and there are rubber gaskets between the plates, which allows or prevent the flow of fluid into the sheet to ensure a tight fit to prevent leaks. Then the heat exchanger plate have groove-like pattern, which strengthen the plates, increase the heat transfer surface area, and create a turbulent flow, which makes heat transfer more coefficient. Next. Then, as you can see from the picture, the gaskets are oriented alternately to ensure the fluid flow do not mix. Then, cool fluid enters through the top of the plate and goes to the down plate. Hot fluid enters through the bottom of the plate and goes to the top of the plate. So this is how the cold fluid passes through the other side of the hot fluid, which is going to take the heat away. As a result, in heat exchanger, the cold fluid will warm up and the hot fluid will cool down. Next. So basically, in the heat exchanger plate, the hot fluid enters through the hot channel, then the plate conducts heat and the plate will warm up. After that, the cold fluid enters the cold channel, and the heat from those plates will start to cool down as the thermal energy is transferred over to the cold fluid through the conduction, as you can see from the picture. Then, when the cold fluid warm up the hot fluid cools down, then the hot fluid cools down, and the heat exchanger will equalize. So the basic principle of the heat exchanger plate is when the cold fluid exit as the warm, then the hot fluid exit as cool. So that's all from me. Now I'd like to pass to my next group.
Okay, thank you, Brother Kamal. Okay, I'll continue from here. My name is Abdul Hamid Buraika, matric number 205111. I will talk about case study of the heat exchanger plate. First of all, we'll see the question. The question says the plate heat exchanger is used to heat 3 meter per hour of milk from 45 Celsius to 72 Celsius using the hot water at 80 Celsius. The exit temperature of heating medium is recorded as 60. The fluids flow counter currently there are two plates made of stainless steel having thermal conductivity of 70. The dimension of the plates are 650 millimeters in height and 400 millimeter in width and 0.5 millimeter in thickness. The gap between each plate is 3 millimeter for the heat transfer confidence on both hot water and milk side. They give us the equation to find the heat confidence, where K is the thermal conductivity of fluid and DH is the hydraulic diameter. The question wants us to find first the mass flow rate of hot water required and the overall heat transfer confidence. Next slide, please. Okay, first of all, we will start with the energy balance equation, which states that heat lost by the water is equal to the heat gained by the milk. We'll use the equation, which is mass flow multiplied with the specific heat capacity multiplied with temperature difference. After we substitute the value that we have, we will get that the mass flow rate is 1.08 kilogram per second. Next slide. Okay. After this, we need to find the heat transfer coefficient with the equation that has been provided in the question. First of all, what we are missing from the equation, it's the DH, the hydraulic diameter, and the Reynolds number, and also the Braden's number. We need to find both of them to apply them in the equation. First of all, DH, the hydraulic diameter, equal to 4A over B. After we substitute the values, we will get it that is 0.4952 meter. Then for the Reynolds number equation, we will apply it to get it. Reynolds number is 16,340 gram, and the Braden's number equation as follow. Then we will get it equal to 1,585.5. Okay, next. Okay, that's all from us, and thank you so much.